Hello guys, welcome back to VC Tech. In today's video, we are going to talk about OSPF, one of the most important routing protocols used in real-world networks. If you've ever wondered how routers automatically find their way from this router up until this router, up until, up until this router, and from this router to the last router, then this video is for you. We'll talk about how network recover when a link goes down, or why OSPF is better than RIP routing protocol. I'll break it down in the simplest way possible, so whether you're a beginner or you're already into networking, you will understand OSPF by the end of this video. So before we jump into the configuration of OSPF on a router, what is OSPF? OSPF stands for Open Shortest Path First. It is a dynamic link state routing protocol that allows router or routers to share routing information automatically. It uses cost base to choose the best path, unlike RIP that uses hop counts. And it is commonly used in enterprise network and ISPs. So why is OSPF important? It is important because it automatically updates routes when the network changes. It also has fast convergence when the links fail. It scales well for large network like the ISPs or enterprise network, and it also supports hierarchy design using areas. OSPF is an open standard configuration that can be done on any router. It is not vendor specific. So the difference between OSPF and RIP is RIP uses hop count as the metric, and remember, RIP has a maximum of 15 hop counts. It is also slow in convergence and limited to small network. However, on the other hand, OSPF uses cost based on bandwidth, and it is fast. It is designed for large network or modern network. So with that being said, guys, let's head over to the configuration phase where we get to configure OSPF on a router. Alright, for this tutorial we are going to be using 4 routers, 2 switches, as we have our 4 routers here, and 2 switches and 4 host PCs. These PCs are the PCs we will be using to ping each local area network to test for connectivity. I've already assigned IP to this device to take 192.168.1.5 with a default gateway of 1.1, and as you can see here also we have the network IP, which is 192.168.1.0, and we also have other IP address for the networks. So for this local area network, it's going to be using 192.168.1.0, and for this network over here is going to be using 10.10.10.0, and for this network it's going to be using 128.64.1.0, and so on. Now this host PC has an IP address. Let's assign IP to the default gateway for this local area network so we can try to ping. I believe this host PC also has an IP address. Yes, it's taking 192.168.2.5 while the default gateway is 2.1. Let's assign IP address to the interfaces of the default gateway of that local area network on the router. We can do that from this and just go to interface gig 0/0 192.168.1.1. This is going to be the default gateway, then you power it on. As you can see, the default gateway for this local area network is active. Let's wait for this to come on. Let's work on this one, this local area network, so we can try to ping So 192.168.2.1, which will be the default gateway for this local area network. A simple definition to what OSPF means. OSPF is how routers decide the best road for your data to travel. If one road is blocked, it quickly chooses another route. Now we are going to configure OSPF on the router's interface to enable communication whenever this host devices on this local area network want to connect with host devices from a different local area network. At the moment, they cannot communicate. As you can see, destination host is unreachable. If we try to ping 2.5, it's also destination host unreachable. Now from this other device, let's try to ping 1.1 network. So 192.168.1. First of all, let's ping the default gateway. Destination host is unreachable. Let's also ping the host device. Destination host is unreachable. First, let's assign IP to the interfaces on the router. Then we are going to configure OSPF to enable communication from this local area network to this local area network. Now let's assign IP address to the interfaces. So interface gig 0/1 will be taking 10.1. I'm just going to do this fast and I'll get back to you guys. Alright guys, so now we've assigned IP address to all the interfaces on the router, as this router has an IP address of 192.168.1.1 and also the 10.10.10.1 network for the interface of gig 0/1. Also for the second router, we have 10.2 and 128.64.1.2 also for interface gig 0/1, which is this interface over here. And for the third router, interface gig 0/0 has an IP address of 128.64.1.1 and also 20.1. For the last router, we have an IP address of 20.2 and 192.168.2.1 for that local area network. Now guys, we've assigned IP address to all the interfaces on the router. Let's try to ping from this local area network to the second local area network and see if we are able to gain communication. As previously, we tried to ping without even assigning IP to other default gateways. We are still getting the same destination host unreachable. Let's check from the second router, from the second local area network. Destination host is still unreachable because we've not configured OSPF, or we've not configured the routing protocol in any of the routers. Now let's configure OSPF on the router to enable the both local area network to communicate. So how do we configure OSPF on a router? We say router OSPF, and we want to give it a certain ID. Now we are in the routing protocol interface for OSPF. First, we want to assign a router ID to this router. We want to give the router an ID. So we have to assign a router ID. The router ID is more or less looking like an IP address. However, it does not have 4 or 2 numbers, just one number. So 1.1.1.1. So this is the router ID for this router. Remember how OSPF works? It advertises all the networks that are directly connected to the router. Now for this router, we have 2 networks that are directly connected to it, which is 192.168.1.0, and also we use a wildcard bit for OSPF. You see, we have to specify OSPF wildcard bit. We do that by saying 0.0.0.255. It's like writing a subnet mask, however writing it backwards. The 255 takes zeros, while 0 take 255. And after doing this, we also have to specify that this is area 0. Remember, area 0 is the backbone of OSPF, and since we are using just one connection, we'll be using area 0 without any other branches connected to it. So we've specified one of the networks. Let's also do the same for the second network and also use the wildcard bits. 0.0.0.255 area 0. Guys, it's very important to always specify the area when configuring OSPF. So we are done configuring OSPF on the first router. Let's do the same configuration on the second router, the third, and also the fourth router. You see router OSPF, we want to specify that as 10. Router OSPF 10. Then we also want to specify a router ID. Remember, every router is supposed to have a different router ID. So this one will take 1.1.1.2. And we also have to specify the networks that are directly connected, which is 10.10.10.0 network with a wildcard bit of 0.0.0.255 area 0. Let's also specify the second network, which is 128.64.1.0 with the wildcard bit of 0.0.0.255 area 0. Now guys, if you watch closely, you're going to see that the router ID of 1.1.1.1 is now neighbor with interface gig0/0, which is this interface over here. And the router ID, remember this router over here has the router ID of 1.1.1.1. This is the router ID. Now it is telling us from this second router that it is now connected to the neighbor router, which is 1.1.1 on interface gig0/0, which is this interface over here. Now let's also configure our OSPF on this router. First of all, before we do that, let's try to ping from this host PC to this interface over here. Remember, they are not directly connected, but because of OSPF, they should be able, this device should be able to ping this interface on this local area network, which is gig0/0 is 10.2. So let's try to ping 10.2, 10.10.10.2. And as you can see guys, we are able to ping 10.2 because we've configured OSPF. Now let's try to ping on this router since we've not configured OSPF there and see what is going to happen. Let's ping 20.1. So ping 20.20.20.1. Destination host is unreachable since we've not configured OSPF. Now let's do that real quick and on the fourth router. So we say router OSPF, then we also want to specify the router ID to be 1.1.1.3. And the networks that are directly connected is 20.20.20.0 with a wildcard bit of 0.0.0.255 area 0. Let's advertise the second network, which is network 128. As you can see guys, that neighbor stuff has not come up, but the moment we connect 128 to the OSPF that we are creating now, it is going to show us that we formed neighbor with the second router. So 64.1.0, the wildcard bit of 0.0.0.255 area 0. Now give it a moment and you're going to see that it's going to form neighbor with the second router. And remember, the first router is already neighbors with the second router, so whatever routes it shares automatically goes to the routing table of the first router. Now, as you can see guys, it has formed neighbor with router ID 1.1.1.2 from the interface of interface gig 0/0. Now let's configure OSPF on the last router, and let's try to ping from that local area network to the other local area network that we did previously, and it did not work. So let's configure OSPF on this router. OSPF. Remember to always assign router ID when configuring OSPF. And let's also advertise the networks that are directly connected, which is 20.20.20.0. Remember, this network is directly connected to the third router, so automatically it's going to connect the fourth router to the third router, and they will be neighbors. Be watchful guys, you're going to see that 255.0, 255 area 0. Let's also advertise the last network, which is 192.168.2.0 with a wildcard bid of 0.0.0.255 area 0. As you can see guys, it has already formed neighbor with router ID of 1.1.1.3 through the interface of interface gig 0/0. Now let's try to ping from this local area network that we tried previously. First of all, let's ping 20.0 and see if we gain connectivity. Yes, we did. Now let's ping 2.5 because previously we tried to ping 2.5 and we were getting destination host unreachable, as you can see here, unreachable. Now let's try to do that one more time and see what happens. Boom, we are able to gain communication from this local area network to this local area network. As if we try to trace routes to see the interfaces that the data or the packets went through, we do that by saying trace route 192.168.2.5, and we are going to see that it left our default gateway, which is 1.1, and it went through the next hub of 10.2 and the next hub also of 192 of 128.64 1.1 and so on until it got to its final destination, which is the device that we were trying to ping. So how we check for OSPF neighbor is, these are the means to troubleshoot OSPF. So we check for the neighbors by saying do show IP OSPF neighbor. So by doing this on the first router, on this router, it is telling us that our neighboring router is this router that has the router ID of 1.1.1.2. As you can see here, the neighbor ID is 1.1.1.2, and it is connected through the interface of interface gig 0/1, which is from this interface. We are able to gain neighbors from this interface over here. As if we check the same for the second router, we should be able to get 2 neighbors. So do show IP OSPF neighbor. As you can see, we have 2 neighbors from the second router because it is connected to this router over here, as well as it's connected to this router over here. That is why you're able to see 1.1.1.3 and also 1.1.1. And next, if you want to check the protocol that the routers are using to communicate, you see do show IP protocol. This should tell you that you are using OSPF routing protocol. And as you can see, it is telling you the routing protocol is OSPF with an OSPF ID of 10. So it is telling you that these are the router ID or the gateways that it is sharing routing table with. So guys, this is how we configure OSPF on a router, and also this is how we troubleshoot if you want to check if the routes are down. When you want to check what route is actually down, you say trace route with the IP address to know where the data is not actually going through. So if you want to troubleshoot OSPF, this is how we do that. And also this is how we configure OSPF on multiple routers to enable communication seamlessly. If this video helped you understand how to configure OSPF on multiple routers to enable devices from different local area network to communicate when there are multiple routers in the network, why not give me a like and subscribe to this channel, because we'll be talking about something more interesting in the next video. Thank you guys for watching, and see you in the next class.